You know, we're always hearing about quantum computing like it's some far-off sci-fi dream. But what if I told you it's right on the edge of completely rewriting the rules of global finance? Seriously, we're talking about a revolution that could change everything from how you invest to the security of your own bank account. So, let's get into it.
Okay, let's just start with a number that's pretty much impossible to ignore. $1 trillion. That is the value that McKinsey estimates quantum computing could generate by 2035. And a massive piece of that pie, up to 700 billion of it, is expected to land right in the heart of the financial world. This isn't just some tiny upgrade. We're talking about a seismic shift.
So, what's the secret sauce here? What makes it so different? Well, it all comes down to the most basic building block. Your phone, your laptop, everything we use today runs on classical bits. You can think of them like a simple light switch. They're either on or they're off, a 0 or a 1. But a quantum bit, or a qubit, that's a whole different ballgame. Thanks to this amazing property called superposition, it can be a 0, a 1, and get this, both at the exact same time. Right. And that single ability, the power to hold multiple states at once, is the source of all of this almost unbelievable computing power. So let's dig in a little deeper and really understand these building blocks. This idea of superposition is really the core of the quantum advantage. It means a quantum computer doesn't have to check possibilities one by one by one. No, it can look at a huge landscape of potential answers all at once. It's kind of like being able to read every single book in a library at the same time. That's the kind of massive parallel processing we're talking about. And once you have that kind of power, you need the right set of tools to use it.
And scientists have been busy building that toolkit. Think of these quantum algorithms as specialized power tools. You've got Shor's algorithm, which is basically a master key that's designed to break the very encryption that protects our digital lives. Then you have Grover's algorithm. It's like a supercharged search engine that can sift through gigantic databases in a flash. And others, with these crazy names like QAOA and VQE, are built to solve some of the most tangled optimization puzzles you can imagine.
Okay, so we've got the theory, we've got the tools. Now for the fun part. Let's see how all of this is going to be applied to solve some of Wall Street's biggest and most expensive headaches. So, take one of the most classic problems in finance, portfolio optimization. Let's say you have thousands of stocks, bonds, and other assets. How do you find the one perfect mix that gives you the highest returns for the lowest amount of risk? I mean, for a regular computer, searching through every single possible combination it's practically impossible. It's a ridiculously huge search problem. But this isn't just a theory anymore. Look at this. JPMorgan Chase has already shown that a quantum approach to this exact problem can cut the time it takes from hours all the way down to just minutes. That's a real-world example of the kind of insane speed-up we're talking about. All right, let's look at another giant computational headache for banks, figuring out the price of complex financial products called derivatives. To get an accurate price, traders have to run millions of what-if scenarios. They're called Monte Carlo simulations. It is slow, it is very expensive, and it just eats up a ton of computing power. But check this out. A really recent study from HSBC and the quantum company IonQ got the same level of accuracy by running just 1,000 quantum shots instead of 1 million classical simulations. That's just a staggering jump in efficiency. I mean, think about that. 1,000 versus 1 million. That right there is the quantum difference. So, quantum computing can build fortunes, for sure, but it can also break them. This incredible power, well, it comes with a pretty serious dark side, a huge threat to our entire digital security system. You see, the lock that protects your online banking, your emails, even top secret government data, it's all based on a very simple idea. It uses math problems that are just way too hard for today's computers to solve. We're talking problems that would take even the fastest supercomputer billions of years to crack. So that leads to a really important question, right? What happens when a totally new kind of computer comes along? One that finds these unsolvable problems actually pretty easy. And this is where that master key we talked about earlier comes back into the picture, Shor's algorithm. It is literally designed to solve the exact type of math problem our current encryption relies on. So once a quantum computer is powerful enough to run this, our standard encryption methods, the ones that secure everything from your texts to your credit card, they become completely useless, broken, wide open. But don't panic. The race is already on to build a much better lock.
scientists are working on two main lines of defense. The first is something called post-quantum cryptography, or PQC. It's basically a new generation of math problems that are hard for both classical and quantum computers to solve. The second is quantum key distribution, which actually uses the laws of physics to create unhackable communication channels. Pretty cool stuff. Okay, so we have this unbelievable promise on one hand and a really serious threat on the other. Let's just take a step back and look at the big picture here. How much of this is just hype, and what are the real-world challenges we still need to figure out? One of the best ways to separate hype from reality is to just follow the money. And as you can see here, governments are pouring billions into this tech. China is estimated to be investing over $15 billion. The US and the EU are also committing billions. This is not some niche academic project anymore. This is a full-blown global strategic race. And here's where that trillion-dollar figure starts to make sense for finance. You can see the biggest prize is in completely changing risk and portfolio management. Derivative pricing is a close second, but even areas like upgrading our cryptography and getting way better at fraud detection represent hundreds of billions in potential value. But look, getting there is not going to be easy. Not at all. Qubits are super fragile. They make mistakes and lose their quantum information really fast. Building these machines is incredibly expensive, and it's hard to make them bigger. We're still trying to figure out which problems actually get a real speed up. And maybe most importantly, there's a huge talent shortage. There are only about 5,000 people with quantum PhDs in the entire world. So when you weigh all that potential against these big hurdles, what does the actual roadmap look like? I mean, when is this quantum future really going to show up in finance? Well, let's look at the timeline. Right now, we're in what experts call the NISQ era. It stands for Noisy Intermediate Scale Quantum. Basically, it means today's early, error-prone machines can already offer an edge for some specific financial problems. By the end of the decade, we're expecting much more powerful machines with hundreds of stable logical qubits. And that big security threat we talked about, the code breaking, that's projected for the early 2030s, with widespread commercial use really taking off after 2035. So this really shows it's not like flipping a switch overnight. It's a phased revolution. For the next few years, these NNIQ machines are going to act as specialized coprocessors, working right alongside our classical computers. Then later, we get into the era of fault-tolerant machines that can handle the really high-value stuff. It's only after 2035 that we might see the kind of universal, standalone quantum finance platforms that people dream about. So what's the big takeaway here? I think it's this. We're moving from a simple, binary world of ones and zeros to one with infinitely more complexity and way more potential. The financial institutions that learn how to exist in this new state of superposition, balancing the reliable systems we have today with the incredible power of what's coming, they're the ones who are going to define the next 100 years of the market. The real question is, who's going to get there first?